Alright, this is chapter 3.1, problem 2. It says state the transformations of x equals y equals x squared. That's your parent function, remember. State the transformations represented by the following quadratic functions. Then graph the parent function and transformed image. And then last but not least, state the vertex. Alright, remember that vertex is the point right there, or if it's like this, point right there. Okay. Also, note that your x is inside and backwards. Alright, and that includes your order of operations. If you have more than one thing going on the inside, you add or subtract, then multiply. Okay? If you are outside, it's y and normal. And that includes your order of operations. You multiply, then add or subtract. Okay, so if you got more than one thing going by, if you're outside, just follow your order of operations. If you're inside, you follow them, but you do them backwards. Okay, everything about the inside is backwards. So, here we go. Letter A. I know it looks like we're just multiplying by 1/2, but we're actually doing two things. Okay, remember, the negative does one thing, the 1/2 does something else. Okay? Now these are outside the parentheses, so they are up and down. They have to do with y. Okay? The 1/2, if you multiply by 1/2 or divide by 2, which is the same thing. Multiplying by half, remember 1/2 x is the same as x over 2. Right, those are equivalent statements. So we are actually, it's a vertical shrink. And you can say by 1/2, or if you say by 2, because it's by a factor of 2, that's fine as well. But it's a vertical shrink by 1/2. Your book is actually going to say, is going to take the 1/2, not just the 2. And that's okay. Now the negative, remember when we multiply by a negative, that is a reflection. And in this case, it's a reflection across the x-axis. Alright, I know it's easy to think y, you think to go across the y-axis, but remember, we're going up and down. So if we start here, if we go up and down, we went across, back and forth across the x-axis. Alright, erase that real quick so we get some room. Alright, so really, there's only one operation we have to do, but it is two transformations. Okay? So here's my parent function, P-A-R-E-N-T, and we'll still do -3, -2, -1, 0, 1, 2, 3, square them, that's 9, 4, 1, 0, 1, 4, 9, okay? And then the new function. Oh, let me plot that real quick. You're up, so go up to 9, left 3, right 3. Go up to 4, 1, 2, 3, 4, go left 2, right 2, go up to 1, left 1, right 1, and 0. Okay? Now, there's nothing going on the inside, so we're not going to change our x's at all. It's still -3, -2, -1, 0, 1, 2, what happened? 1, 2, 3, okay? But your y's, I know this is two transformations, but we can just divide by -2, and that's okay. So 9 divided by -2 is -4.5. 4 divided by -2 is -2. 1 divided by -2 is -0.5. 0 is still 0. 1 divided by -2 is -0.5. 4 divided by -2 is -2. And 9 divided by -2 is -4.5. Okay, I just took all my y's and divided them by -2. Or you can think about multiplying by -1/2. But again, it's the same thing. So negative 3, 1, oh,
pretty much made up my decision.
negative 4.5, 1, 2, 3, 4.5. So that's about there. Alright. Negative 2, negative 2. Negative 1 is 0.5. So remember, just if it's 0.5 or 0.7, just estimate it the best you can. And 0, 0, well, they share a point right there. So this graph is a little wider.
I'm thinking it's a hell of a
Okay.
about that analogy, considering
And there's the new one.
had a really bad problem with
Cool. Letter B, same idea. We've got anything inside is x, anything outside is y. Inside is x backwards, outside y is normal. Inside is x backwards, outside y is normal. Alright, so now remember backwards. So if you're multiplying by 2, the opposite of multiplying is dividing by 2. So that's what you're actually doing to all your x values, is what you're really doing. So is this a shrink or is this a stretch? It is a shrink. So it is a horizontal. Remember, your horizontal is your left and right. Shrink by 2. So instead of multiplying all the x's by 2, we're going to divide all the x's by 2. And then we got this plus 1 outside. And that is a shift. You're adding or subtracting, that's a shift. And it's on the y-axis, so if you go up, if you're going positive, you're going up, so it's a shift. Up. 1. So here we go. Your parent function, P-A-R-E-N-T, X, Y. It's a horrible Y, but whatever, you can go with it. Okay, I'll fix it. Negative 3, negative 2, negative 1, 0, 1, 2, 3, 9, 4, 1, 0, 1, 4, 9. Alright, parent function, new function, x, y. Oop, let me graph the parent function right quick. 1, 2, 3, 1, 2, 3, 4. 2, 2, 2. Alright, the new one. Remember, we're dividing all of our x's by 2. So negative 3 divided by 2 is negative 1.5. Negative 2 divided by 2 is negative 1. 1 divided by 2 is negative 0.5. 0 divided by 2 is still 0. 1 divided by 2 is 0.5. 2 divided by 2 is 1. And 3 divided by 2 is 1.5. And then we have to add 1 to all of our y's. That's not so bad. So 9 plus 1 is 10. 4 plus 1 is 5. 1 plus 1 is 2. 0 plus 1 is 1. 1 plus 2 is 1. 1 plus 1 is 2. 2 plus 1 is 5. 4 plus 1 is 5. I'm going too fast for my mouth to keep up. Okay, so there's your new function. So negative 1.5, 10. So I'm going to go up to 10 and go about 1.5 out. Alright. Negative 1, 5. 1, 2, 3, 4, 5. Negative 0.5, 2. 0, 1. And I'm just going to plot the rest of my points. And your graph looks like that. Alright. Oh, I forgot. State the vertex. State the vertex. Well, the vertex for this one is at 0, 0. The vertex for this one is at 0, 1. The vertex right there. Okay?